Hi, I'm Kathy Manley. This video covers Lesson 4, Sequencing with Scrat from Course A. There are 3 lessons that we've asked you to do with your students this fall. Those include Lesson 1, Safety in My Online Neighborhood, Lesson 3, Happy Maps, and Lesson 4, Sequencing with Scrat that we will cover today. There are awesome additional lessons that you may also want to do with your students, so we encourage you to explore the course. The purpose of this video is to outline computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies to incorporate in the lesson, to model pedagogical strategies for implementing the lesson, and to review computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies addressed in the lesson. Computational thinking concepts are the concepts programmers engage with as they program. In this lesson, students will focus on sequence as shown in bold. Powerful ideas are skills within a domain that change how we think or perceive the world and problem solve. The powerful ideas that operationalize computational thinking are also the computational practices that programmers develop when they engage with the computational concepts. We will focus on decomposition, algorithm, and debugging as shown in bold. For more detailed information, you can rewatch the computational thinking concepts and powerful ideas videos on our website. Students will use additional critical thinking skills such as compare and contrast, cause and effect, predict, problem solve, plan, and observe. In this video, I will walk through this lesson and point out opportunities to use the following pedagogical strategies to support student learning. We will use student-centered learning, where students have time to play, think, and code, as well as direct instruction on key elements. We will also use the PRIM approach, where students predict, run, investigate, modify, and make a program. Lastly, we will focus on the process of problem solving. After completing the warm-up and bridging activities, you will introduce programming with the video Intro to Code Studio. Reinforce the vocabulary introduced. Compare and contrast the happy maps with the online puzzles. Then have students pull up Lesson 4 and go to Puzzle 2. This puzzle helps students practice using the blocks. Show students how to click the speaker icon in the upper right corner of the instruction box to have the instructions read to them. Students will drag the E block up to connect to Run. Have students observe the code, discuss how the steps they see are an algorithm. Have students make a prediction about what will happen when they click Run. Keep the PRIM approach in mind: predict, run, investigate, modify, and make. Talk about cause and effect. When I press Run, the cause, Scrat performs a behavior of moving to the right, the effect. By attaching the block to When Run, students have created a program telling the computer what behavior or task to perform. When they click Continue, they'll move on to puzzles 3 through 5. This is where students learn about dragging the blocks to build the code. Encourage students to ask each other for help before asking you. When they get to puzzle 5, please note that students can pass puzzle 5 without removing the last block. So you may need to show the students that they should only be using 4 blocks. Right now there are 5. So when they remove that last block, they will have 4 out of 4 blocks. And then they'll press Run. As students finish these puzzles 3 through 5, give them time to play, think, and code. They can either, if they've clicked continue, they can go back to puzzle 5, or they can just click on replay, and they can play around with these steps. They can change the sequence or order of the steps and press Run. Remind them of the PRIM model. They can make a prediction about what will happen when they press Run. As you bring students back together, talk about the sequence and why the order of the steps was important. You can also click on Show Code in the upper right-hand corner of the screen and have them compare and contrast the written code to their blocks. Remind them that both of these are algorithms. When we put the algorithm into a language the computer can use, we've written a program. They are all programmers now. Then you'll move on to puzzles 6 and 7, where students will use problem-solving skills to complete the code. Identify the problem, decompose the problem into smaller steps, plan the steps just like they did when they worked on Happy Maps. Remind them again of the PRIM approach. This is also a good place to discuss debugging, the process of finding errors in the program when it's not doing what they wanted it to do. The key is to slow the students down to focus on the process rather than taking a trial and error approach by trying different blocks. When you wrap up, ask students what they learned. Remember, play is part of learning, so encourage them to share fun aspects as well as the computational thinking concepts and powerful ideas that they remember. Review problem solving to encourage them to not just jump into dragging the blocks. Talk about the role of observation. Ask them what they did when the program didn't work the way they expected. Remind them that fixing a program that isn't working is called debugging. Ask them if the sequencing order of steps mattered in their puzzles. And reinforce their skills by bringing out the flurb and fruit pieces from lesson 3 or having students create their own puzzles for classmates to solve. Let's take a moment to debrief. We covered several computational thinking concepts and powerful ideas that aligned with this lesson. In sequence, we discussed whether the order of the steps mattered. The order of the steps in the online puzzles mattered because they had obstacles that needed to be avoided. Decomposition, when talking with students about breaking the problems into smaller steps, you help them decompose the larger task. Students should be more familiar with the term algorithm as a list of steps now. And debugging is a process of finding bugs or parts of the program not working properly and fixing the problem. We applied critical thinking skills by having students compare and contrast the online puzzles with the flurb and fruit activities, observe blocks and make predictions, solve problems and make a plan. We also employed a variety of pedagogical strategies by encouraging students to play, think, and code while providing direct instruction for key elements. Students also focused on understanding the problems, devising solutions, and using the PRIM approach to investigate and make their programs. When you're working with the students, it can be helpful to reinforce this vocabulary, especially in other classroom activities, to reinforce the skills they're learning here. We encourage you to address additional computational thinking concepts and powerful ideas whenever the opportunity arises. Thank you for watching this video.